Hello guys, in the last class we talked about a particular example where we used our basic binary operations as a case study for our distributive property. We'll be continuing. Remember figure 4. We have x plus y times z, and then we are asked to determine if this operation is distributive as an element where x, y, and z, remember x, y, and z remain elements of the set z plus, which is being expressed as the set containing positive integers, that is positive whole numbers. So in this case, for distributivity, I know I have to say what my x plus y times z. Using the knowledge of distributivity, I know I have to separate this. I have to say x plus y, then take the sign at the center, put it here, and then say x plus z. Now I have to determine if these two are equal, and then I have x, expanding this one I have x plus yz, expanding the other I will have x squared plus xz plus xy plus yz. So this is what I have here, and then I realized that these two are totally different. And then we realize that since they are totally different, then we can say then we can say that the operation, since the left hand side is not equal to the right hand side, then we can say the operation x plus y times z is not distributive under set z plus. So, looking at the Roman figure 5 now, the fifth one, we have a question here that asks us about to see if x minus open bracket y plus z is distributive under set z plus. X minus y plus z. To determine if this is distributive, we need to express this as this for the left hand side, and then for the right hand side we'll be having it as x minus y plus x minus z. Expanding the right hand side, we'll have x minus, we're using our minus to open the brackets, we're having minus y minus z. For the right hand side, we'll be having x minus y plus x minus z, which will be giving us x minus y minus z equals to, our x plus x here will give us 2x minus y minus z. So we know this is what we have, and then we realize that this two, the left hand side is not equal to the right hand side. So you can see, because of this one has 2x and this one just has 1x, this is the left hand side is not equal to the right hand side, then the operation x minus y plus z is not distributive under set z plus, not distributive under set z plus. So for the last one here, we'll be considering the operation x times open bracket y minus z. That's Roman figure 6. X times open bracket y minus z, where x, y, and z are elements of the natural set of natural positive integers rather. So we know for distributivity, this will become x times y minus z equals to x times y minus x times z. And we know this then will become x into brackets y minus z, and this one will be xy minus xz. This will be xy minus xz equals to xy minus xz. So looking at these two, we realize that both of them are equal. Because they are equal, then I can say that since the left hand side is equal to the right hand side, then the operation here, the operation x times y minus z is distributive under set z plus. So this is where we call it a day. in this class. In the next class, we'll be looking at another property of binary operation, another law used in the binary operation